Hello, 6th grade scientists. Today we're studying volume, another property of matter. So yesterday, if you remember, we talked about mass and weight. We talked about their differences, but also how they were interrelated. So today we're moving on to volume. So if you get your interactive volume lab, get that paper out and go ahead and follow along. Write down the answers with me. And this needs to be uploaded. It is due by April 14th. All right, here we go. So first of all, volume is the amount of space an object takes up. So the space an object takes up is, for instance, like this Rice Krispie box, it's how much stuff it can fit inside of here. Okay, so volume can also be thought of as a rectangular prism, how many blocks, how many tiny blocks I can fit inside of here. So how many blocks would equal the volume? And these blocks are centimeter cubed blocks. So that would tell you the volume, how much is contained in this rectangular prism. All right, so volume can be measured in two different ways. Volume can be measured in milliliters or liters. And it can be measured, or it can be measured in cubic centimeters. So liters and cubic centimeters kind of go back to the question that I had for today, which is, why is volume measured in both milliliters and centimeters, centimeter cubes? So when I look at that, that's kind of contradictory, because we've got milliliters, which tells me liquid, and we've got centimeters, which tells me length. So I'm not really sure about this. And right here, I just made the statement that it's measured in milliliters and liters, which is liquid, or cubic centimeters. I'm going to have to come back to that. I'm not really sure yet. So when we measure a three-dimensional shape for its volume, it can be measured length times width times height, and by a ruler or a yardstick. So that's something that I can use a ruler in order to measure, and then multiply that, and then that answer would be the volume of that object. But there are some objects that we just can't measure by doing the length, the width, and the height. Like this little Lego man, Minecraft Lego man. I'm not going to be able to measure his length, his width, and his height. That would be too hard to measure like that. What about this bling bling ring? There's no way I could measure the length, the width, and the height of this thing. So how would I measure that? Well, that comes to the next part of your notes. If something is irregularly shaped, like one of these objects, we have a totally different way of measuring it. So a regularly shaped object would be like a rectangular prism, like a cereal box, or like my favorite, a pizza box. So those could be measured length times width times height. But the irregularly shaped objects would be measured in milliliters or liters. And we would use a graduated cylinder to determine how much water it displaces. Now, if you're wondering, because inquiring minds always want to know, 1 milliliter is equivalent to 1 cubic centimeter. Just store that in your memory bank. All right, so now that we have all this information, then I'm going to go ahead and start measuring. And we're on part 1 of the interactive lab, measuring regular three-dimensional shapes. So rectangular prisms would be a regular three-dimensional shape. A cube would be a regular three-dimensional shape. It's something that we could use a ruler or a yardstick in order to measure. All right, so let's get started with the pizza box. So to begin with, I have to determine the height. That's going to be the height. We have the length, and we have the width. All right, so when I measure this pizza box, I've got a little problem here, because I've got my ruler and it only goes so far. I don't have a yardstick. Actually, my yardstick broke. So what I'm going to have to do is I'm going to have to go ahead and measure. I've got it measured down to here. This would be 30. And then I'm going to move my ruler, and then I'm going to look again, and this is an additional 16. So the height of this is going to be, oh, wait a minute. Oh, I got the little lip there, 17. So this is going to be 47 centimeters, all right? So there's the height. Now I'm going to measure the length. So I've got, again, the same issue I had before. I'll go ahead and measure it here so you can see. All right, so I've got the 30. And then I measure out here, and I've got an additional 16. So I've got 46 centimeters. All right, now I've got to measure the width. And the width is right here. And I measure that at 5 centimeters. So now I have all of my information in order to find the volume of this pizza box. Or if I filled this pizza box with those centimeter cubes, how many of those cubes would I get inside here? So I've got 46 for my length, and I've got 5 for my width, and 47 for the height. So when I multiply that, I've got 46 times 5, and you can do this on your calculator. So if you said 46 times 5 is 230, you are absolutely correct. So then we do 230 times 47. Multiply that. 10,810. If you said that, you are absolutely correct. So the volume of this pizza box is 10,810 centimeters cubed. So that's how many of those cubes would fit in here. I'm not going to put that many cubes in there. That's weird. All right, so now I'm going on to my Rice Krispie box. So my Rice Krispie box, where did my, there it is, my ruler. All right, so I'm going on with my Rice Krispie box, and I'm going to start off with the length. And the length here is 19 centimeters. So I've got 19 centimeters for my length, 19 centimeters. Now I'm going to do the width. And the width is a little bit wider than the pizza box. It's 6 centimeters. And the height. So I've got, maybe this will fit, nope. All right, so I've got over there, and then that would be 30 plus 3 more, 33 centimeters. All right, so now I've got 19 by 6 by 33. So get your calculator ready. 19 times 6. If you said 114, you are absolutely correct. So we need to do 114 times 33. Ready? 3,762 centimeters cubed, or cubic centimeters. All right, so that's how many of those cubes would fit inside this Rice Krispie box. But I'm not going to put those in there. Don't have time for that. All right, so we found the volume of regular three-dimensional shapes. Now, what about these other things that I had? I have the Lego Man and the ring. So, I have my graduated cylinder, and I've got this filled with water, but I put green food coloring in there so it'll be a little easier to read. One thing that I want to point out before I begin, and it's in your notes on the top, it says that the water, when you're looking at the water, because it sticks to the sides, you have to look at at eye level what the lowest point is. That's called the meniscus. So you have to look at that lowest point, and that lowest point is what you're going to read as the answer. Okay, and I have that in your notes right here. So to get an accurate reading, you have to look at the low point there. All right, so we're going to use the graduated cylinder to tell how much water is displaced. So since I'm using two objects, I'm going to have to pour this out and then put it back in. So I'm going to have to reread to make sure it's accurate before I do the second object. So for the first object, and I'm looking at the chart on your interactive notes, and I'm looking at part 2. So it says object Lego man. So we're going to do the Lego man first. So the volume of the water before adding the object. So I'm going to take a look at this, and I need to leave it on the table to read it. So I'm going to look down here, and it's 70 milliliters. So go ahead and write down 70 milliliters. All right, and I'm getting ready to put this Minecraft Lego man in for a dive. All right, you got the 70 milliliters written down? Okay, so here we go. So in goes the Lego man, and up goes the water level, and now it is at 75. So before we did anything, it was 70 milliliters. Now with the Lego man, it's 75 milliliters. I need to find the difference between these two. Now they look backwards right now, so when I subtract it, I have to be thinking 75 minus 70, obviously. Biggest number always goes first with subtraction. So I've got 70 milliliters. It changed to 75 milliliters. So the difference between those two is 5 milliliters. So the volume of my Lego man was 5 milliliters. And I need to get this guy out of here. And without making a mess, get the water back in there so I can figure out the volume of the ring. So I know the volume of the Lego man is 5 milliliters. So I wonder, is this ring going to have more volume or less volume? I don't know. I'm not sure. I think it might have more. It seems like it's a little bit larger, but I'm not positive. Okay, so let's go ahead. I've got to reread this for accuracy. And I'm looking at this, and it looks like, oh gosh, it looks like it's a little less than 70 now. I think it's 68. So we're going to start it off at 68 milliliters. I think I lost some water in the cup here. So I'm going to go ahead and drop my ring in. Ooh, that made a bigger mess. And this looks like, hold on. This looks like it's 72 milliliters. So 72 milliliters after the ring was put inside there. So I've got 68 at the beginning, 72 at the end. I know that in order to go from 68 to 72, I have 4. So 4 milliliters for the ring. All right. So in conclusion today, before we conclude, why is the volume measured in milliliters and centimeters cubed? Well, now you know. If it's a regularly shaped object, it would be able to be measured in centimeters cubed. So if you can measure it with a ruler, centimeters cubed, like my cereal box and my pizza box. If it's an irregularly shaped object, like my Lego man and the ring, it's going to need to be measured with the displacement of water, which would be milliliters or liters. Okay? So now we've answered the question. So now, in conclusion, volume can be measured in centimeters cubed or milliliters, depending on if it's a regularly shaped or irregularly shaped object. If it's regularly shaped, it's measured with a ruler or yardstick, and then the length, width, and height are multiplied in order to find the volume. If it's irregularly shaped, it can be measured in a graduated cylinder, viewing the displacement of the water. Keep in mind, when you're looking at the water level, you have to look at the lowest point. Because the water sticks to the sides, you have to look at the meniscus. The difference between the milliliters of the object before the object is put in there and after the object is put in there gives you the volume of that object. All right? Okay. I hope you remember this because we need volume and mass in order to do density, and density is tomorrow. So I've got a few videos for you to watch. I want you to watch those videos, fill these notes in. These notes have to be uploaded for a grade. And I'll see you next time. Keep watching and always keep learning.